We all know that artificial intelligence can learn, right? It can build on its knowledge to do some absolutely incredible things. But what happens when that old knowledge, instead of helping, actually holds it back? Well, this exact problem has a name: negative transfer. And it's one of the biggest challenges we face in building smarter and, frankly, more reliable AI.
So let's just start with that really simple but powerful question. What actually happens when an AI learns the wrong things? Because as we're about to see, the consequences go way beyond just a few errors. They can have a huge impact on the real world. But before we get into where things go wrong, we've got to appreciate the amazing idea that lets AI learn in the first place. I'm talking about its ability to build on what it already knows instead of having to start from scratch every single time. Okay, so the magic behind all of this is a technique called transfer learning. Here's a way to think about it. Imagine a brilliant chef who has completely mastered French cooking. Now, if they want to learn Italian cooking, they don't have to relearn the basics, like how to chop an onion or balance flavors. They transfer that existing knowledge, and it makes learning the new cuisine much, much faster. That's pretty much exactly what AI does with transfer learning. And this whole process is really only possible because of these massive, pre-trained models that come out of major research labs. You probably heard of them, models like Google's BERT or OpenAI's GPT-2. They've been fed just enormous amounts of text and data, creating this foundational knowledge base that other, more specialized AIs can then build on. They're like the giants whose shoulders new AIs get to stand on. And here is where our story takes a little bit of a dark turn. What happens when the knowledge from that first task doesn't actually help with the new one? What if it actually makes things worse? This is the core problem of negative transfer.
To put it really simply, negative transfer is when the old knowledge an AI has conflicts with the new job it's given, hurting its performance instead of helping it. All of a sudden, the model's past experience becomes a liability, not an asset.
Let's go back to our chef for a second. Imagine they're a master of delicate, intricate pastries. Now, those amazing skills are not going to help them grill the perfect steak. In fact, all their fancy pastry instincts might just lead them to completely burn it. And that, right there, is the heart of negative transfer, when expertise in one area leads to total failure in another. So, why on earth does this happen? Well, researchers have pointed to 4 main culprits. Let's dig in and break down the big reasons why an AI might learn the completely wrong lessons from its past. So here's the breakdown of what can go wrong. It really boils down to 4 potential points of failure. First, there's a mismatch in context, what we call domain divergence. Second, the learning algorithm itself might just not be the right tool for the job. And then third and fourth, the problem could be in the data itself, either the original source data or the new data it's trying to learn from.
Let's kick things off with domain divergence. Imagine an AI that was trained on really formal, official Thai documents, so it knows proper grammar, vocabulary, sentence structure, the whole shebang. Now try to get that same AI to understand all the slang and abbreviations used on Thai social media. You see, the context, the domain, is just worlds apart. Its formal knowledge is almost useless here and could lead to some major misunderstanding.
Second cause, sometimes the problem is the tool itself. The algorithm, which is just the set of rules for learning, might not be smart enough to figure out which knowledge is useful and which bits it should ignore. It's kind of like trying to use a hammer for every single task. It's great for nails, sure, but it's terrible for screws. The algorithm just wasn't built to adapt.
The third culprit is poor source data. I mean, if the foundation is cracked, everything you build on it is going to be cracked too, right? A perfect example is Wangchen-Berta, a well-known Thai language model. It has its limits, a finite vocabulary, some issues with how it breaks down certain words. So when you use this model for a new task, you don't just transfer its knowledge, you transfer its weaknesses too. And finally, the problem isn't always with the original model. Even if you start with a perfect AI, if the new data you're feeding it is messy or full of errors or there's just not enough of it, the AI is going to struggle to learn correctly. It's that old saying, garbage in, garbage out, and that applies just as much to the new information as it does to the old. Okay, so now we know the causes. Let's talk about the sticks. And look, this isn't just some abstract technical problem for researchers. When AI learns the wrong lessons, it has serious real-world consequences. One of the absolute most dangerous outcomes is AI bias. If a model's original data doesn't properly represent a certain group, that's representation bias, it will carry that fundamental flaw into every new task, leading to really unfair outcomes. Or if it's trained in a way that just confirms existing human prejudices, it will amplify those biases wherever it's used. This is how flawed learning can actually automate discrimination.
And the scale of these problems is just staggering. Take misinformation. Between 2019 and 2023, Thailand's Anti-Fake News Center tracked over 1 billion suspicious messages. Now, an AI suffering from negative transfer, maybe one trained on real news but unable to adapt to the tactics of fake news, it won't just fail to catch this stuff, it could even be used to generate and spread it even faster. The stakes get incredibly high in areas like healthcare. Think about HealthLink, which is a platform in Thailand for sharing patient records. If an AI used there is biased, maybe because its source data was skewed towards one demographic, it could lead to unequal access to care or totally flawed medical advice. This isn't some what-if scenario. We're talking about critical, real-world life or death risks. So how do we move forward from here? The goal isn't to stop AI from learning, obviously. It's about guiding it to learn the right things. Let's take a look at the strategies for building a more responsible and effective AI. The solution really starts with a change in mindset. To fight negative transfer, developers have to accept that bias from source data is pretty much a constant risk. This means being transparent about what a model was trained on, constantly monitoring how it's performing on new tasks, and, crucially, being ready to step in and correct course the moment its old knowledge starts causing new problems. So on a technical level, this really involves a three-pronged attack. First, you clean up the data as much as possible to remove biases before you even start training. Second, you choose algorithms that are specifically designed to be fair. And third, you review the AI's outputs after it makes a decision, just to make sure the outcomes are equitable for everyone. And this really points to a huge shift in thinking. As the expert Teresa Rodriguez de las Heras points out, the focus is moving away from just the code inside the algorithm and more towards the real-world context where the AI is actually being used. Because at the end of the day, what really matters is the impact these systems have on people's lives. Which brings us to our final and most critical question. You see, AI is basically a mirror. It reflects the data we feed it and the goals we set for it. And since these systems are literally learning from us, the responsibility falls squarely on our shoulders to be better teachers. So how do we make sure that what they're learning are the right lessons?